All right, cool. I had some questions come in on interferometry, so I wanted to go over those real quick regarding absolute space and what they mean by how they're deriving the distance and the there and back trip for light and all that. So I'll just kind of read off what Kevin asked and we'll get into the explanation. So Kevin poses the question: at Michelson-Morley, how is the counter path of each direction calculated in the equation? To me, it's not that intuitive that the perpendicular beam lagging behind the other one uh, uh, wouldn't cause the opposing reflection direct direction back to the mirror equal to the first one. So he's basically saying, wouldn't it cancel out on the there and back trip? How are they accounting for that? I read that it is accounted for in the equation, but I'd like to know exactly how that's happening. The whole experiment doesn't seem as simple as Austin describes it. And then Alexander says, how I interpret it is that the beam is going sideways as a diagonal route, which is always longer than the straight path. So great, great questions, great observations, great ways to try and look at the experiment. So I'll give my explanation here. So when we go back to the original Michelson-Morley paper here, they give how they're deriving it with the equation. They got their 2D times v squared over v squared, where the capital V squared is the speed of light, the little v squared is Earth's orbital velocity, the distance is the path length, which we'll go over in a second, and the 2D, right, the 2 is the coefficient for the there and back distribution of the path length of how they are, measuring with an orthogonal setup where it's there and back, right? And so the path length, or so the distance here, the D, the area or the length, all the same. You could, it's based off of this right here. So the source, right, and then the distance to this mirror and back, and this mirror and back, and this mirror and back, and also when it hits this splitter, this mirror and back, this mirror and back, this mirror and back until it gets recombined, and then hits the photographic screen right here where the fringe patterns are projected. So the full distance of that is what they add up. So when they say, I think it was 67 meters or 64 meters or something like that. So when that's what they derive that distance off of, right? So when they have the there and back, that's their there and back distribution. And then when you get into like the Sagnac effect and circular, or I'm sorry, circular rotational interferometry, right? With this kind of setup, the same thing. So they would have your angular rotational speed would be your omega, and then you would have 4 pi for that. So actually, I'll break it here. So you would do 4 omega times the area over c squared times lambda. So this would give you the angular rotation times the area, and your area would be in the same respect of how it was derived in the Michelson-Morley experiment. The total, like the length that light has to travel from this mirror to 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 the photographic plate, and then going back in the opposite direction, right? And then it's a rotation, so it's 4x, right? Or so they 4x it, right? You break it into 4 quadrants of the rotation. That's the way I look at it anyway. And then it's over the ratio of c or c squared times lambda, and that will give you the relevant fringe shift pattern to the wavelength for the linear, right? So this equation here, this 2 VL over C lambda is the same as this. Oh, sorry, as this one. So when they talk about absolute space and when they say that the length or that the distance is increased on the arm, or like that's how they're talking about it, right? So they're saying that the speed of light would be retarded when it's in the direction, or when it's going against the direction of ether flow, or in this case, the way that they were looking at it with the stationary ether, it would be retarded in the direction of motion when it's, um, when it's like, it's basically just resistance, right? When the orbital motion plane is, what is it, parallel to the ether, to the stationary ether, that's when you would get the resistance. So that's when light would be retarded. So when they say that um, that the distance changed in the arm. That's kind of how they're talking about it. They're invoking an absolute space to preserve the distances to explain the variance. That is how they're talking about it. Now that's when Einstein comes in and says that they don't need to explain anything with absolute space in his theory. So he removes that component and he says that linear motion actually can't be measured, right? And it's all relative. But there's no absolute space to explain these measures for relative motion. It has to be relative to something. So he gives his postulates for relativity in his 1905 paper, and he says that we don't need no luminiferous ether. It will prove to be superfluous in so much as here as the theory developed will not require an absolute stationary space provided with special properties, nor will we invoke a velocity vector to a point in empty space in which electromagnetic processes took place. And what he means by that is suppose this device is rotating, right? And you have this red beam here coming towards this mirror. It gets split. It's heading towards this B mirror, right? But this B mirror is in rotation, so it's changing, right? So what they're kind of saying is that the distance that you're predicting in this equation, right, with the area or the length, is actually changing based off of the preserving it in absolute space. So you could assign velocity vectors for electromagnetic propagation to go through empty space where the where the where the electromagnetic propagation already occurred, so that they can combine that to say that the distance increased, right? So this is like a hypothetical way of analyzing it. That's like a mathematical framework to analyze the motion within the ether framework. Einstein saying that, well, no, we don't need that. Now, to quickly separate the mathematical representation of the concept of absolute space and whatnot, right, is separate from the mechanical concept from the mechanical measurements that the ether provides to motion, right? So like the physical fringe shift patterns, motion being directly relative to it, the variance in the speed of light showing in that. So that's a physical component that's separate from the concept of absolute um, space and how they talk about it through the math side of it. So I just wanted to be clear on that. But yeah, when they're analyzing it in that's how they talk about it, or that's one of the ways that they talk about it. So Einstein's saying we don't need to do that, but then Sagnac came along and showed that rotation has a direct first order effect that can be measured with a first order measurement. So when they get this relationship here, right, the rotational speed is directly predicts the velocity to the when it's ratioed against the speed of light. You get the fringe pattern that's directly proportional to it. So he showed, oops, there is an absolute space. So Einstein had to say, well, that's only in regards to rotational effects. That's why they say rotation is a special case and it has to be treated as acceleration, right? And they have to use general relativity to explain it, because through general relativity they can apply different metrics to an acceleration to make it equivalent, using gravitation, to then make it equivalent to special relativity to all be in alignment, right? So it's all a convoluted rigmarole, but the reasons that they have to do it is because it turns out that there is an absolute space for linear motion and rotational motion, but they threw out the linear motion absolute space to save the heliocentric model, right? To tell everyone, don't look at these first order measurements, don't look at the first order ratio that you can derive, right? Because when you do the Michelson-Morley experiment and you get these fringe patterns, okay, you get these fringe patterns, right? And you apply them back. Well, the ratio you get isn't 30 kilometers a second; it's 6 kilometers a second, right? And using the same ratio with rotation, you find like Sagnac found. I forget how fast this table was rotating. Um, I want to say it was 13 rotations a second, but I can't remember. But anyway, it was directly proportional to how fast his table was rotating, right? Dufour and Pruner did the same thing, found that it was proportional to its rotation. Same situation. So it's more and more of the exact same, in regards to first order effect of velocity being ratioed against c, and there being a first order measurement in the fringes of that. So they just had to keep telling everyone to ignore that for linear motion. Can't be done, can't measure it. There's no absolute space for linear motion. Don't look here, right? So I hope that kind of clarifies on the use of absolute space and the confusion when they talk about the distance change versus an actual distance change. And that's not to be confused with length contraction, the mechanism proposed to explain the inverse relationship, to explain the fringe shift pattern from our reference frame versus a reference frame on the sun. Different kind of contraction of the space mechanism, or of the dimensions of the coordinate system used to describe the space. But anyway, all right. If you have any further questions, feel free to ask. Keep going, keep researching. This is an awesome subject, and when we really hammer this out, it's the most significant argumentation that we have, because when you get into Michelson, Gale, Pearson, like I showed last night, bring this up real quick. Boy, MGP, GP right here. So they go on to say that there's a translational speed measured in this in this closed loop setup, but ignore that, because we're throwing out translational speeds. We're going to look at this through an angular rotation, right? And then they apply an angular rotation of 1,000, or was it 1,600 1 second, 1,600 kilometers a second, relative to the equator, and then they make that fit for the Earth's angular velocity, and then they explain that as the sidereal rotation. This is how they did it, right? So they took a measurement of 3 kilometers a second relative to the, what was it, the 41st latitude, and then said, no, ignore that. Check out our ratio where we introduce Earth's rotational speed that we need for to break in the 15 degrees per hour relative to the equator. Here's real quick. All right here. So when they get in this right here, this omega, this this phi here, this is your latitude, angular rotation that they cooked in to ignore the first order measurements of the velocity. So what you would have if you didn't ignore that and insert their own ratio there, this would be 3 kilometers a second at the latitude. All right.